This is the video solutions for the complex multiplication homework. This is based on the lecture we had in class. So notice here we are multiplying two complex numbers together. And recall that we have a string of multiplication. What I mean by that is 3 times I times 4 times I is really what this is here. And again, the order in which you multiply doesn't matter. You can write this as 3 times 4 times I times I. Now, what we know is we can multiply 3 times 4, and we'll get 12. We then multiply our I times I, and we end up with I squared. Now, what we do here is we're going to replace I squared here with the value of -1. So wherever I see an I squared, I replace it with -1. This is what was based in the class. We talked about this. And so this number here of I squared is -1. And so we really have 12 times -1, which is actually -12. So we're going to use the fact that I squared is the value -1. Number 3. -2i times 5i. And again, we have multiplication. But this is really -2 times I times 5 times I. And then we have the string of multiplication in which the order in which you multiply doesn't matter. We can write this as -2 times 5 times I times I. I'm going to multiply my -2 times +5, which gives me a -10, times my I times I, which gives me I squared. Now, wherever there's an I squared, I replace that with the value of -1, so that I have -10 times -1, which gives me +10. Number 5, -5i times -4i. Again, a multiplication question. We're going to drop the parentheses and we're going to write it as -5 times I times my -4 times my I. Let's notice we have again a string of multiplication. The order in which we multiply doesn't matter, so I'm going to rearrange the order of my numbers here. And so I can multiply my -5 times -4, and that will give me a +20. Don't forget here again, I have I times I, which gives me I squared. I squared is the value -1. So I'm going to replace I squared with a -1. We get 20 times -1, which is -20. And we're done. Number 7, 3i times 1 minus 4i. We're going to use the distributive property. So 3i times 1 is 3i minus 3i times my 4i. I'm going to rearrange the order here, where I have 3 times 4 times I, and I'll have 3i minus 12 times my I squared. Don't forget to replace -1 with the I squared here. What you end up with is 3i minus 12 times -1, or 3i plus my 12. I'm going to write this as a complex number, 12 plus 3i. And we're done. Number 9. Negative 6i times 2 minus 5i. Again, we're going to distribute. Negative 6i times my 2 minus the, let's write it this way, 5i times a negative 6i. Let's do some multiplication here. The first term here that we see, we could take the negative 6 and multiply it with positive 2 to get negative 12i. We then can take the negative 5 times the negative 6, which gives us positive 30. And don't forget we have I times I, which gives us I squared. Now, the value of I squared again is negative 1. So we have negative 12i plus 30 times negative 1, negative 12i minus 30, write it as a complex number, negative 30 minus 12i. We're done. Number 11. We're going to use the distributive property. Negative 3i times negative 8 plus negative 3i times I. We're going to multiply our negative 3 with our negative 8 to get negative 24i plus a negative 3i times an I is negative 3i squared. Don't forget the value of I squared is negative 1. We'll obtain negative 24i plus a negative 3 times a negative 1. Get negative 24i plus a positive 3. Write this as a complex number. You have 3 minus 24i. Number 13. 2 minus I times 3 plus I. Notice that this is a multiplication question. We're going to have to use FOIL. So I'm going to use a FOIL box, and my rows is 2, I have a row 2 and a row negative I, column 3, column I. Let's remember here that these two terms are my rows, and the next two terms are my columns. We're going to multiply every row with every column. So I'll do this carefully here at first. Notice we get 2 times 3, 2 times I. We get negative I times 3, and we get negative I times I. So for each of our boxes here, remember that we have our first terms. This is our first term. This is our outer term, our inner, and our last. And 2 times 3 is going to give us 6. 2 times I is simply 2i. Negative I times 3 we write as negative 3i. And negative I times I is negative I squared. Let's bring down our terms. 6 plus 2i minus 3i minus I squared. Don't forget to replace negative I squared with negative 1. So we'll get 6 plus 2i minus 3i minus a minus 1, or 6 minus I plus 1. 6 plus 1 is 7. we have 7 minus I. Number 15. 2 plus I times 3 minus 2I. We're going to have to use FOIL. Our FOIL box has row 2, row I, column 3, column negative 2I. Two times 3, 2 times negative 2I. I times 3, I times negative 2I. Now 2 times 3 we know is 6. 2 times negative 2I is negative 4I. We write this as 3I, and we have a negative 2I squared. Okay, let's bring down the terms. 6 minus 4I plus 3I minus 2I squared. I squared has a value of negative 1. 6. Negative 4I plus 3I is minus I. Minus 2 times negative 1. We get 6 minus I plus 2. And then 6 plus 2 is 8. We get 8 minus I. (17) 5 minus 4I times 1 minus 2I. FOIL. Row 5, let's put it up here. Row 5, that's fine. Row negative 4I. Column 1, column negative 2I. In case you forgot, my 2 rows. My 2 columns. We're going to multiply every row with every column. So 5 times 1 is 5. And if we want to be careful, we'll go through every detail. 5 times 1, 5 times negative 2I, negative 4I times 1, negative 4I times a negative 2I. We'll get 5, negative 10I, negative 4I, and 8I squared, because a negative 4 times a negative 2 is 8. It's positive 8. Negative times negative is an 8. I times I is I squared. 5 minus 10I minus 4I plus 8I squared, where I squared has the value of negative 1. 5 minus negative 10I minus 4I is minus 14I plus 8 times my negative 1. We get 5 minus 14I minus 8. We'll have a negative 3 minus 14I when we combine like terms. (19) 3 plus I times 3 minus I. We're going to need our FOIL box. 3I, 3 minus I. Now, 3 times 3, 3 times negative I times 3, I times negative I. 3 times 3 is 9. 3 times negative I is negative 3I. Then we have a 3I, negative I squared. 9 minus 3I plus 3I minus I squared. Let's remember what happens here that's interesting, since we we have conjugates. We got a first term, outer term, inner term, last term. Whenever you have conjugates, if we combine like terms here, we have 9 minus 3i plus 3i. If I owe 3 apples and have 3 apples, my apples are gone. What that simply means is the O and the I term always cancel. We're just going to be left with the first and the last term. Negative I squared has a value of -1, so we'll have 9 minus -1, or 9 plus 1, which is 10. (21) 5 minus 2i times 5 plus 2i. Notice again we have conjugates. We're going to use FOIL. We have 5, the negative 2i row, 5, positive 2i column. 5 times 5, 5 times 2i. Negative 2i times 5, and negative 2i times 2i. 5 times 5 is going to be 25. 5 times 2i is 10i. Negative 2i times 5 is negative 10i. Negative 2i times positive 2i is negative 4i squared. Notice again, the O and I terms are going to go away. F-O-I-L. Negative 10i plus 10i is 0. That's gone. We bring down our terms. 25 minus 4i squared, where my I squared has a value of -1. 25 minus 4 times -1 gives us 25 plus 4, or simply 29. 23. 6 plus 5i times 6 minus 5i. Again, we use FOIL, and notice we have conjugates. What we could use is a shortcut that we've seen in class. Remember, let's write this down. Here's a fact. A plus bi times a minus bi will be a squared plus b squared. We actually proved this in class. So how we use this here is to notice that my a here is 6. My b here is 5. We have conjugates because their signs alternate, plus and minus, they're opposites. So how we use this here would be to simply say that 6 squared plus 5 squared will be the product. We have 36 plus 25, and that will give us 61. We could use this fact about conjugates. (25) 2 plus 3i times 2 minus 3i. Again, we have to use FOIL, and we have conjugates. Going back, let's remember, we multiply conjugates. The sum is going to be a squared plus b squared, or the product is a squared plus b squared. In this case, my a is 2, my b is 3, so that 2 squared plus 3 squared is 4 plus 9, which is 13. Number 27, we're going to divide now. We're going to, in some sense, rationalize the denominator. Our denominator down here, if we notice, is imaginary. We have a value I there, if you want to think of it that way, or letter I. It's a complex number, and we can't have an irrational number or a complex number in our denominators. We don't mind if they're in the numerators, but not in the denominators. So we're going to multiply this by, let's go through every detail, the things we did in class. I'm going to multiply this by the number 1. And remember again that 3 over I times the number 1 can be written as a fraction. And I'm going to write it this way. I'm writing it as this red over red, meaning I can put any term there that I want, as long as it's the same term on top and bottom as a numerator and a denominator. So I'm going to put an I and an I, and then notice that I divided by I is the value 1. So we preserve our equality here, and when we multiply fractions, we multiply horizontally across. 3i over I squared. Now remember, I squared is the value negative 1. So this will become 3i divided by negative 1, or simply negative 3i. Positive divided by a negative is a negative. This is what we're going to use with most of these problems. 29, we have 2 divided by 3i. Again, we're going to multiply top and bottom by the same fraction. I over I, which is really the number 1. So we preserve our equality, and multiplying these fractions, we get 2i times 3i squared. Again, the I squared is the value negative 1. So this will become 2i over 3 times negative 1, or simply 2i over negative 3. A positive divided by negative is a negative, and so this is negative 2i over 3. Notice there is no imaginary number or complex number in the denominator. This is just a real number value. This is what we have to do. 31, 6 over 5i. We're going to multiply the top and the bottom by the same term, I over I. When we multiply fractions, we multiply horizontally across. So we get 6i over 5i squared. I squared is the value negative 1. So we have 6i over 5 times negative 1, which is 6i over negative 5, negative 6i over 5. And we're done. This is number 31. 33. 10 plus 6i divided by 2. Now notice here, we're rationalizing the denominator, or they call this complex division, but in the denominator, we simply have a real number, in this case 2. 2 is the real number. This is not imaginary, it's not complex. So we're not dividing by an imaginary or complex number, we're dividing by the real number 2. So this becomes a simple, straightforward, in some sense, distributive property, in that we're dividing or distributing the division to both terms, 10 and 6i, the sum, by the number 2. Since the number 2 is dividing what we see on top here, 10 plus 6i, make sure the number 2 divides both terms, 10 and the 6i, and they're connected with the addition here. So now I have two fractions to evaluate or simplify, and 10 divided by 2 is 5. 6 divided by 2 leaves me 3, so I get 5 plus 3i. And I'm done. $35. I have 10 plus 6i over 2i. Now, in this problem here, this is different than 33. 33, we divided by the number 2. 35, we're dividing by 2i. This is a complex number. 2i here, complex number. We're rationalizing the denominator. So make sure then we distribute the division for both of the terms for the sum with your 2i. So again, notice I got a 10 plus 6i here, where 10 plus 6i is being divided by 2i. They still are being divided by 2i, just separately. That's your division property, your distributive property here. We're going to divide, though. So let's simplify each fraction, and let's notice that 10 divided by 2 is 5. So I get 5 over I plus my i's cancel, and 6 divided by 2 is 3. So this is just the number 3. Now, consider the fact that I have to rationalize that denominator. There is an I in my denominator here. I'm going to divide by the I. So how you really do that again is, let's look at the work. 5 over I, again, times a fraction where I and I, or I divided by I is 1. And this is multiplication. 5 times I will give us 5i over I squared by multiplying the fraction. I squared is negative 1. We get 5i over negative 1, or simply negative 5i. This is what 5 divided by I really is. So I can write this as negative 5i plus 3, or 3 minus 5i written in complex number form. This is my final answer. $37. We have 25 minus 15i divided by 5i. Again, we're dividing by a complex number. And this time we're dividing a difference. So make sure your 5i divides both terms. You are distributing, in some sense, this division of 5i. And so 5i is dividing both terms. Now, if we simplify, 25 divided by 5 is 5. I get 5 divided by I minus I and I cancel. 15 divided by 5 is 3, so I get 5i minus 3. What a coincidence. 5i minus 3, we actually did 5i plus 3. So let's remember what happens here. I can write this as negative 3 plus 5 over I, and again, multiply top and bottom by I over I, which is 1, and I get negative 3 plus 5i over the I squared, and my I squared is negative 1, so we'll have negative 3 plus 5i over negative 1, or negative 3 minus 5i. And you're done. 39. 4 minus 10i divided by 5. Notice again, we are not dividing by an imaginary complex number. We're dividing by a real number, 5. So all that's left for me to do is actually simplify, because this is in a complex number form. This is of the form, if you remember, a plus bi. That's our complex number. My fraction 4/5 can't be simplified. But 10 is divisible by 5. 2 times is the quotient there. So I have 4/5 minus 2i. And let's write this nicely. 2i. And you're done. This is in complex number form. Number 39. Number 41. We have 2 minus 10i divided by 4i. Notice in this problem here, we're dividing by a complex number. So make sure that complex number of 4i divides the difference, divides both terms. Your 4i is going into both terms here. So let's simplify here. We have 2 over 4i minus 10i over 4i. Now, 2 and 4, well, 2 isn't divisible by 4, but I can simplify this. 4 can be written as, if you want to do it that way, 2 times 2, where my 2 cancels. Don't forget there's an I down here. So I'll have really 1 over 2i minus, and on the other side here, I can write 10 as 2 times 5 and 4 as 2 times 2. I's cancel, a 2 cancels. We're left with a minus 5 halves. Okay. Let's switch the terms so that we can prepare to give our answer in complex number form. Now be careful though. We're going to have to rationalize the denominator here. I have a complex number on the bottom. So I'm going to put a note here that 1 over 2i, I'm going to have to multiply top and bottom by the fraction I over I, which is 1. And I'll get 1 over 2i squared. And my I squared is negative 1. So I get I over 2 times negative 1, or simply minus 1/2 I. This is different. Your I is the numerator now. Maybe you want to write it this way. I want to point out this detail. That now you have I in the numerator position, not in the denominator position. I can get rid of this part because I rationalize the denominator. And in fact, this is a minus 1/2 I. So I write it as minus 1/2 I. And you're done. This is 41. 43. 6 plus 10i over 3. And again, notice we are actually dividing by a real number and not a complex number. So 3 has to divide both terms. 6 divided by 3 is 2. And I cannot simplify 10/3. So this will be 10/3 I. Notice again, I write my answer as a plus bi. I write it in complex number form. And this is number 43. 45. 3i over 1 plus 2i. So notice again here, I have a complex number in the denominator. I have to multiply by 1 again. Now, the fraction here that I'm going to use is going to be special. Remember from lecture, we're going to take advantage of using the conjugate. And that is the conjugate of 1 plus 2i is 1 minus 2i. So 1 minus 2i divided by 1 minus 2i is the value 1. So we can actually do this when we multiply our fractions. We always multiply horizontally across. So I get 3i times 1 minus 2i over 1 plus 2i times 1 minus 2i. Now, consider what happens here. On top, I just use my distributive property. On the bottom, I use FOIL. But there's something special about using conjugates. If you guys remember, I have 1 plus 2i, and then I have not 1 plus 2i again, I have 1 minus 2i. I have its conjugate. So let's recall. Let's recall the fact that we use. Here's our fact. We have a plus bi times a minus bi. When I multiply conjugates together, that's a squared plus b squared. There's no imaginary component. This is a real number. This is what we're going to use for our denominator. So in the denominator, we end up with 1 squared plus 2 squared. We're going to evaluate that. In the numerator, I use my distributive property. So 3i times 1 is 3i. 3i times negative 2i is 6i squared. I squared again is negative 1. So let's write down what this is. 3i minus 6 times negative 1 over 1 plus 4, which is 5. We get 3i plus 6 over 5. And again, this is going to be dividing both terms. We're dividing by a real number. So we're going to use, again, that distributive property. We're going to distribute the division to both terms by 5. And notice we can't simplify these fractions here. So we're going to write this as a complex number. 6/5 plus 3/5 I. Notice it's of the form a plus bi, which is a complex number. This is number 45. 47. We get negative 2i over 3 minus 2i. Again, we're going to multiply by the number 1. Only this time, again, I notice I have 3 minus 2i. I have a complex number. We're going to have to use the conjugate. So here's what we get. Negative 2i times 3 plus 2i divided by 3 minus 2i times 3 plus 2i. I distribute in the numerator, use FOIL in the denominator. However, remember, we're multiplying conjugates. Let's go back. Let's remind you. 3 plus 2i, or 3 minus 2i, and 3 plus 2i are conjugates. When you multiply conjugates together, we have 3 squared plus 2 squared. Distribute the numerator. Negative 6i minus 4i squared. I squared is the value negative 1. So we have negative 6i minus 4 times negative 1 over 9 plus 4. Let's put this on top. Negative 6i plus 4 over 9 plus 4 is 13. We're dividing by a real number, not a complex number. Negative 6i over 13 plus 4 over 13. None of these fractions simplify. I write my final answer in complex number form. 4 over 13 minus 6 over 13i. This is in the form of a plus bi. That's 47. (49) 6i over 1 minus 4i. We're going to multiply by a fraction that's equivalent to the number 1. We're going to use the conjugate of 1 minus 4i, which is 1 plus 4i. So we'll get 6i times 1 plus 4i over 1 minus 4i times 1 plus 4i. Notice again, we have 1 minus 4i and 1 plus 4i. These are conjugates. In the numerator here, we are going to simply distribute. So 6i plus 24i squared over 1 squared plus 4 squared, which is 6i plus 24 times negative 1, because I squared again is replaced with negative 1. The denominator has 1 plus 16, or simply 17. So let's write this up here. 6i over 17 minus 24 over 17. Notice that these fractions don't simplify. I'm going to write this as negative 24 over 17 plus 6i over 17. I am writing this in complex number form, a plus bi. Number 51. 2 plus 3i over 1 minus 4i. We're going to multiply by a fraction that's equivalent to 1. Again, we're going to multiply by the conjugate of 1 minus 4i, which is 1 plus 4i. When we multiply, we get 2 plus 3i in the numerator, 1 plus 4i, that product, over the product of two complex conjugates. So this time in the numerator, we're going to have to use FOIL and not the distributive property. We're going to need a FOIL box. The denominator is also FOIL, but as you've seen from past examples, we're actually looking at the product of conjugates. So this denominator again, like from the prior example, will be 1 squared plus 4 squared, which we found to be 17 in the denominator. So remember that this number goes down here, 17. Now, we just need a FOIL box to multiply the numerator together. And so I'll have 2, and I'll have a 3i, I have 1, and I have a 4i. So 1 times 2, let's enter the information in the FOIL box. 1 times 2 is 2. 2 times 4i is 8i. 3i times 1 is 3i. 3i times 4i, 12i squared. I squared is a value negative 1. So all my terms are going to be the following. 2 plus 8i plus 3i plus 12 times negative 1, or 2 plus 11i minus 12. I will end up with negative 10 plus 11i. This is going to go up here. That's in my numerator. So, negative 10 plus 11i over 17. Both terms are being divided by 17. So I get negative 10 over 17 plus 11 over 17i. I can't reduce these fractions, and I'm writing my answer in complex number form. A plus bi. Number 53. 1 plus I over 3 plus 5i. Again, we're going to multiply by a fraction that's equivalent to 1. Meaning, I'm going to use the conjugate of 3 plus 5i, which is 3 minus 5i. We're going to get 1 plus I times 3 minus 5i over 3 plus 5i times 3 minus 5i. In the numerator, we use FOIL. In the denominator, we use FOIL. But again, remember, we're going to multiply by conjugates, or cousins. Your denominator is going to be now 3 squared plus 5 squared, or 9 plus 25 is 34. That's going to go in the bottom. The numerator needs a FOIL box, so I'm going to have 1, I'm going to have I, 3, minus 5i. Let's enter the information in our boxes. 1 times 3 is 3. 1 times negative 5i is negative 5i. I times 3 is 3i. I times negative 5i, negative 5i squared. Replace your I squared with negative 1. We end up with 3 minus 5i plus 3i minus 5 times negative 1, which is 3 minus 2i plus 5, or 8 minus 2i. This goes in my numerator. So let's write down what we have here. 8 minus 2i over 34. 8 minus 2i over 34 becomes 8 over 34 minus 2i over 34. We're going to simplify. 8 is 2 times 2 times 2. 34 is 2 times 17. 2 goes away, 2 goes away. I'm left with 17, and I have an I. 2 goes away, 2 goes away. I have 4 over 17. So 4 over 17 minus 1 over 17i is my final answer. And I've written this in complex number format. A plus bi. And you're done.